Hey guys, welcome back. In this, we'll be trying to solve the problem of the day in Geeks for Geeks of 7th November. All right, it's called weighted job scheduling. Now, this is a hard problem. At least on lead code it is. Here they're saying medium. I'm not really sure why. I'll do my best to explain how this works. All right. Now, I'll give you the basic idea of what they are saying. All right. You have a multi-dimensional array called jobs. Okay. Inside this array, you have many subarrays. All right. Inside the subarray, your first index informs you as to when the job starts. Your second index, or like your index one, explains when the job ends. And your last index will tell you the profit you can earn from the job. All right. Now, the objective is you have to find out the maximum profit you can earn by scheduling non-overlapping jobs. Okay. Now, for example, if I talk about this particular case, your answer will be 250. Now, the reason for that is you can choose the first job and the last job, right? Because the last job begins when the first job ends. And the overall profit we can make is 200 plus 50, that is 250, right? Yeah. If you think about any other way, you can't make a profit no matter what you do. Like, say, for example, you take this job and this job, right? So you earn, now we can choose these two because this job starts at 6 and this job ends at 2, so it's starting only after the first job ends, but the overall answer you get is 100 plus 50, that is 150, right? So you have to choose the ones which gives you the maximum answer. So let's see how we can solve this. All right, okay, so I'll be explaining my best. All right, now the first thing you have to do is you have to sort it based on the ending value. Okay, based on the ending value of the jobs, you'll have to sort the array. Now, I'll explain the reason for this. Now, the reason for this is that if you sort it based on the ending value, we just now like we'll go through each of these subarrays individually to find the maximum profit we can earn up till that subarray, right? So, like first we'll go through, let's say the first subarray, we'll find the maximum job we can, or like the maximum profit we can make till this subarray. Then we'll go to the next subarray. We'll find the maximum profit we can make till this subarray and so on. Right. Now, this job will be a lot easier if we sort our main array depending or based on the ending value of the jobs or when the job ends. Now, the reason for that is, say for example, all right, say for example, I want to find the maximum profit which can be made up till this job. Okay. I don't have to look forward and backward for it, right? If I sort it based on the ending time of the jobs, that means I just have to look behind this job. I just have to look for this job and this job, right? Why? Because the ending time for these two jobs are lower than this job, right? So I just have to look backward from the index where I am at. So there is no need for me to look front and back because say for example it is unsorted. I will have to look both front and back, right? So the complexity will be much more in that. So in this case, we will sort it. Now, fortunately, in this example, it is already sorted based on that, right? You have 2, 5, 19, and 100. It is already sorted based on when the job ends. Okay. Now I'll be explaining what we have to do, right? In case I can explain the approach till now, you guys might have guessed it. We need dynamic programming to solve this. All right. Now I'll say why. So we'll be having a dynamic programming array, as I said in all my earlier videos, right? You'll have an array for the number of subarrays you have. So we have 1, 2, 3, 4. So 0, 1, 2, 3. All right. Yeah, I guess this should do. All right. So now what will dp of 0 be? dp of 0, as I said, each of these indexes will represent the maximum profit you make up till that particular index. All right, as simple as that. So now, say for example, I'm starting from the first index. Okay, I'm starting from 0, 0, 1, 2, 3. Now 0 represents this particular subarray, right? Now this is our first subarray. There is no subarray that comes before this. So what is the maximum profit I can make up till this subarray? The answer is 50 itself, right? Because no subarrays come before it, so I don't have to look for that, right? So I just have to look till where I am at right now. All right. Now the reason for that is, as I said, we are sorting it so that we just have to look behind the current subarray we are at to check if any other jobs can be done along with our jobs that don't overlap. Okay. So yeah, hopefully you guys got it here. Now I'll move forward. Okay. I'll move forward. Now we'll go to this subarray. Okay. So now once I go to this subarray, what is the profit I have right now? The profit I have right now is $20, for example. Okay. 20 is what I have right now. All right. Now I can go backwards. Okay, I can go backwards. Now, one more thing I have to say that when we search backwards, we will be using binary search. All right, to find the most probable job which can give us the most profit without like overlap. We'll be using binary search because it's off log n. Now, if we go through every single job in order, the complexity becomes way too much. Like it might not seem useful as of now because you only have one array which we have to check. But like say for example, you had 100 subarrays like this to check. It's most efficient if you do it using binary search. All right. Anyways, let's move on. Okay. Now we'll check the array which came before this. All right, which is this particular array. Now, what is the first thing you have to check? The first thing to check is if the zeroth index of our current array is more than or equal to the first index of the array we are looking at right now. Why? Because we don't want the jobs to be overlapping, right? We have to ensure that the subarray we are at right now starts only after the previous job gets over. All right. So now it is right. 3 is more than 2, right? So it's good in that stage. All right. Now what will we check? Now we'll basically check as to what can I say? We can add the profit now, right? Now since this condition is satisfied, there is nothing else to look at basically. Okay, so what we do? We add the profit to our current profit. So current profit is basically 20 bucks, or it was 20 bucks. Now we got 50 bucks extra. So we'll add 50 to this, which makes our total to 70. All right. And I also like forgot to say initially DP, everything will be initialized to 0. Okay. Now what will we check? Now we'll assign this to DP. Now we won't simply assign this to DP, right? We will be assigning what? The max value of what is there currently in the DP with the value we have right now. So if you compare 0 and 70, 70 is bigger, right? So we can just directly remove 0 and put 70 inside of it. All right. Okay. Now, let's move forward. Okay, let's move towards the next element. Now we'll move to this particular subarray. Okay. Now here, let's see how much value we get for this. Our current profit will be the current profit of our current subarray right now, which is 100. Okay. Now we'll go to the subarray before it. All right. Now what do you see here? What we see here is that it's 5, here it's 6. So it is all right in that case, right? Our current job executes only after the previous job got over. That's very good. Now what can we do? We can just add the profit of this particular job with the profit we have right now, right? 100 plus 20. 120 is what we'll be having, right? Okay. Now, one thing is, since we have the answer stored in our DP array, we don't have to manually check like this, right? We can just directly see if 5 is lower than 6, we can directly add DP of 1 to our answer. So we can directly add 70 inside of our answer, right? So I can directly do 100 plus 70, which will be 170 bucks. Now the reason for this is at DP of 1, we already calculated, right? Like before DP of 1, if you will go and if you will search, 70 is the maximum profit you can get. We already calculated that. So there's no need to check it again. So we'll just directly add the value of DP of 1 with the current value we have. Right, so it's 170. Now we check if DP of 2 is bigger or 170 is bigger. 170 is bigger, so we add the max value into our DP of 2, that is 170. All right, well and good. Can drop all of this. Now what can we do? Okay, fine. Now we go to the next subarray. All right, so I'll drop all this. We go to this subarray. Okay. Now we check 19 and 2, right? Now this is not right because we can't execute the current subarray. Well, the reason being that the previous subarray didn't finish executing, right? So basically this job gets finished at 19, but our current job begins at 2 itself. So we can't use this. So we cancel this out. Then we go back. Can we use it? No, because this job ends at 5. Our job starts at 2 itself, so we can't use this. Now we'll go to this. This job ends at 2. Our current job also starts at 2. So it's completely fine. So our current profit is what? Initially it was only 200. Now we found out that the element at the 0th index, or in this first subarray, satisfies the condition we want. So what will we do? We will add dp of 0 to this. So plus dp of 0, right? That will come up to be 200 plus 50, 250, right? That's basically it. So now what can you do? You can just rub this. You can add 250 inside of this, right? That's basically how you solve it. And now you output this last value as your answer. That's basically your answer. All right? Yeah, that's how you solve it. Now let's try and code this out. Okay, so let's code this out. As I said, the first thing you have to do is you have to sort it based on the ending value, right? So I can just use lambda here, is equal to lambda um, x of I, right? Now there's one way to do it. If you want, you can also do it manually, but that'll be a lot longer. All right. Now you can set n to be the length of jobs just for easier calculation. Now dp will be equal to 0 into n because we need an empty place for every single element that we have. And dp of 0 will be equal to jobs 0 of 2. Basically, your first job's profit. All right. Now here's what we do. We go to every single job after that. So for I in range, right, 1 to n. Now instead of this, the current profit. So I can just do current profit will be the profit of our current jobs, the job I of 2, right? As simple as that. Like this is very understandable code, so you guys should have no issues in understanding this, right? Now we have to do our binary search. As I said, to every single subarray we go to, we will check every subarray that comes up till there, and we'll do binary search on that, so we can find out with optimality as to which profit will give us the maximum amount, right? So I can just do low equal to high. I mean, low comma high is equal to 0 and I minus 1. Okay, and like we do I minus 1 because we don't want to exceed the current index we are at, right? We have to look to all the subarrays which comes before the subarray we are at right now. That's the reason we do I minus 1. Then I can just do selected is equal to minus 1. Now this basically says if you selected a profit or not, right? While low is less than high. Actually, we can put equal to if I'm not wrong. I guess this should be fine, right? Yeah. If so, then what can we do? We can calculate your middle element, right? Classic binary search. So low plus high by 2. I can't find the, yeah, okay, fine. Now what can we do? We have to check if the jobs of mid of 1. This basically checks if, what can I say? The ending time of the job which you're going through right now is less than or equal to the starting time of our job that we have right now, right? It's less than or equal to jobs of 1 or I0. All right. Over here, one small syntax error. Jobs of mid 0. Should be like this. All right. Yeah. Now, if this is the case, then what can we do? We can just put selected equal to mid. Right. We are choosing the point right now. Then we can set low is equal to mid plus 1. Just how binary search works. And if not, we can just decrement the value of high, right? We can set high is equal to mid minus 1. Now, in this way, it's a lot more efficient. If you have to do it linearly using a normal loop, it would take way longer, right? Now, if selected is not equal to minus 1, basically, if we chose something, we have to check if the current profit, right? Your current profit will be the value of dp of selected, right? As I said, we just look into our dp array for the values which we have stored already. So you don't have to check them again. Now at the end of this, we can just directly say dp of I is equal to max of current profit, or dp of I minus 1. Now this is because, say for example, we calculate the current profit of the subarray we are at right now. If it comes to a lower value, if it comes to a lower value than the previous answer we got, we shouldn't put that as dp of I, right? Because we want the highest value up till the current array we have. So if it is lower than the previous answer we'll have, we'll put the previous answer itself for the current subarray's answer. All right, as simple as that. Now at the end, we can just do dp of n minus 1, right? Yeah. Let's see if this works. Okay, let's see. Current profit, line 11. Okay, it should be jobs, not job. Yeah, guys, one small error I made in this. We should return this outside the for loop. Let's check now. There we go, it works. Let's submit. There you go, that's how you solve this problem. If you have any doubts, do let me know in the comment section down below. And that's it for this video. I'll see you in the next one. Goodbye.